We're going to talk about population dynamics. In this section of the course, there's really just a lot of terms that you need to know, terms that refer to populations and interactions between populations. So here's the first list of terms that you should be familiar with. And one that you're definitely going to see is this one, the difference between interspecific and intraspecific competition. So both of these refer to a type of competition, obviously. When I think of these two terms, I always think of the word international. International refers to different countries. So in the same way that international is different countries, interspecific refers to different species. So interspecific competition is competition between individuals of different species. On the flip side, intraspecific competition is competition between individuals of the same species. So there's the first topic. Now let's take a look at a few examples here. So here we see, it's kind of faded a little bit, we see what looks like a lion and a jackal or a hyena fighting over some kind of carcass, pardon me. So they're competing. And if you realize, obviously the lion and the hyena are different species, therefore that would be an example of interspecific competition. Here we've got a picture of a bunch of piranhas finishing off something that was unfortunate enough to get caught in that water. Now all of these piranhas are the same species and they're clearly competing for what little food there is available. But because they are the same species, that is intraspecific competition. So that's intra. Whereas the different species is interspecific competition. Now up here, this diagram up here illustrates something called the competitive exclusion principle, or Gauss's principle. Now that theory states that no two species can occupy the same niche in an ecosystem, because if they do, they're always going to be competing. And when they're competing, one of them is always going to be slightly better at competing. So the first two diagrams show the population of a certain kind of paramecium that's grown in a laboratory. So this species, when it's grown on its own by itself, you see a population curve that looks like this. And this is a different species, and you can see when it's grown by itself, it would show a population curve that looks like this. But when you grow the two species of paramecium together, this is what we see. Now you can see that not much changes for this species, okay? But you can see that this species is not doing as well as it would be if it's on its own, as you can see by this diagram. Now this is the competitive exclusion principle. Obviously these two species are competing for the limited resources in that laboratory setting, in that petri dish. And this guy, this population, is obviously the better competitor. This population is not as good a competitor, and you can see that they're clearly losing the battle. So that's a really good illustration of the competitive exclusion principle. It's important you understand how the populations of predators and predators and their prey affect one each other. And you can see that if we're looking at a graph over time of a prey and predator population, you can see that they affect each other and that it's cyclical. It kind of goes in a cycle. So the black line illustrates a prey population, the red line illustrates the predator population. The prey population would always be bigger than the predator population, because if there was too many predators, then they'd eat all the prey, and then they'd have nothing to eat themselves. So you always see fewer predators than prey. So if we take a look at this section of the graph, okay, so we see in this section of the graph the population of the prey, is increasing. And because there's more prey available in an area, so there's lots of bunnies moving into an area, well, that's going to attract a lot of predators. So because of all these bunnies moving in, we're all of a sudden going to see a lot of coyotes moving in to take advantage of that. But when all these coyotes move in, well, they're going to start eating up all the rabbits. So as you can see, the population of predators increases, the population of the prey is going to decrease. And now there's not enough food for all these coyotes, so they have to leave or go find food somewhere else. So now we can see the population of predators is going to decrease. And now that the population of predators is low, the population of prey can increase again. And so it goes on, but you can see how the two populations affect each other. All right, symbiosis. I know you've learned about this in grade 9, and there's 3 kinds of symbiosis, but it's a kind of association between two different species. A close association, so they're usually living in close proximity to one another. And there's 3 kinds. And we've got happy faces and smiley faces, or in some cases neutral faces, to indicate that some species are benefiting from these relationships and some are not. So the first one is parasitism. And you probably know what a parasite is. A parasite is something that lives inside of a bigger animal and eats up all their food and causes them harm. So that's what we see here. In one species we have a sad face, so that would be the host of the parasite who's being hurt by this relationship. And then we have a happy face, so that would be the parasite who's obviously benefiting from this relationship. And the next one we have mutualism. Mutualism is when both species benefit from this relationship. So we have 2 happy faces. And lastly we have commensalism. Commensalism is when we have one species benefiting and one species that, and here we have neither a happy or a sad face, just a neutral face. This species is not benefiting from this relationship in any way, and it's not being harmed in any way either. So let's take a look at a couple of examples. So here we have an example of mutualism. We have some kind of antelope living in close proximity to this special kind of bird. Now as the antelope is living in the forest or in the savannah or wherever it is, it's occasionally going to pick up ticks and other parasites. So these birds, luckily, like to eat those ticks or parasites. So both are benefiting from this relationship. The antelope is being cleared of its parasites, and the bird is getting a food source. So that is mutualism. Here's an example of parasitism, and you can see it's a close-up shot of looks like some kind of hookworm. And you can see that this worm uses these teeth-like structures to attach onto its hosts in the inside of its intestines. Now, human beings don't often get these, but certainly if you had a dog, it could get a hookworm or a tapeworm. So these things hook onto the inside of the intestines of the dog. The dog goes out and eats, finds the food, eats the food, digests the food, and then that food passes through the intestines, and this hookworm is just going to take in all that nourishment. So the hookworm is benefiting because it's getting a food source. The dog is being harmed because it's eating all that food but not getting any nourishment from it. And lastly, here we see an example of commensalism. We have a hermit crab and a sea anemone. Now the hermit crab is not affected by the sea anemone, so it just goes about its daily business. Now the sea anemone is benefiting because when it attaches to the crab's shell, and as the crab moves around, it is being exposed to new areas where it can gather food. So the sea anemone on its own does not move, and it catches its food with these little tentacles. But if it can't move on its own, then it's kind of stuck to one spot. But if it's able to hook on with a hermit crab, it's able to move from area to area to be exposed to new sources of food. All right, so a few more interactions here. So I'll leave this slide up for you to look at, and then let's take a look at some examples. So the first one we're going to look at is mimicry, and there's 2 kinds of mimicry. There's Batesian mimicry, and there is Mullerian mimicry. And in both these examples, we have 2 species that resemble each other and derive benefits from resembling one another. So let's take a look at this one. This is Batesian mimicry. Here we have 2 snakes, 2 different species of snakes. They look the same, but there's a major difference, and that is that this one is venomous, poisonous, and this one is not. Now, we see in nature a lot of times is dangerous animals are very conspicuous. They have bright coloration, and then other animals know just instinctively that they're dangerous. They see these bright colors and they know to stay away. So this guy is dangerous and other organisms would tend to stay away. This guy is not dangerous, but because he resembles the other guy, potential predators are very likely to stay away from it. So that's called Batesian mimicry. In this case, we have one dangerous species and one non-dangerous species that is being protected because it resembles the dangerous species. Now down here we have what's called Mullerian mimicry. And the difference is, again, we've got two species that resemble each other, but the difference is that in this case both of these species are dangerous. So if you were a bird and you saw either a cuckoo bee or a yellow-jacket wasp and were silly enough to try to eat it, you might get stung, and you would know for the future, well, to stay away from that guy because it could hurt trying to eat it. And it really wouldn't matter if it was the cuckoo bird that you tried to eat or the yellow jacket that you tried to eat. And because these guys both resemble each other, if in the future you saw either one of them, you would likely stay away from them. So this is Mullerian mimicry, and again, both of these guys are benefiting from the fact that they're both dangerous and they both resemble each other. A couple more examples. This one and this one. These are two examples of protective coloration, two specific examples of protective coloration. As the name suggests, protective coloration means the coloring of your body gives you some kind of protection. This one is called cryptic coloration. Cryptic means hidden, and what this basically is camouflage. And you can see, it looks like an octopus of some kind, very well blending into its surroundings. So a potential predator might swim right by and not even notice that it's there. So that's cryptic coloration, that's camouflage. This one, on the other hand, is called aposematic coloration. And it's exactly the opposite. Instead of trying to stay hidden, it has a very distinct, conspicuous coloration pattern. And like I mentioned before, other animals instinctively know when they see an organism that's very brightly colored, they stay away because they know that it's very poisonous. This is a poison dart frog, which is one of the most poisonous animals on Earth. So that's aposematic coloration. A little bit about age structure diagrams before we go. An age structure diagram can tell us a few things about a population. It can tell us about the different age groups. It can tell us about how quickly or how slowly a population is growing. It can also tell us about mortality rates and natality rates. But basically what it is, it's a pie graph of a graph of a population broken down into the various age groups. So you can see on the side we've got a key of the various age groups, and we can see for each of these populations a different size block which gives a relative idea of how many people are in that age group. So for this population, you can see in the 0 to 4 category there's fewer people than there is in, let's say, the 45 to 49 age group. Okay, so what does this tell us about a population? Number one, these diagrams tell us how quickly or how slowly a population is increasing. So you can see down here it says that this is a rapidly growing population. Okay, now how do we know that? Because if we look at the biggest age group in this population, it's the young part. Okay, so the individuals that are either in reproductive age or soon will be in reproductive age. And if the biggest part of your population is reproducing, then you can imagine in the not too distant future there's going to be lots and lots and lots of babies being born. So this population you can see is growing quickly. On the other hand, you can see that here the percentage of the population that's in childbearing range or will be in childbearing range is not very high. So not many people are going to be having kids, so this population is actually going to be getting smaller. So what does this tell us about birth rate and death rate? Well, if we look at the number of old people in each population, it can tell us about death rate. This population, you can see there's a lot of people in the older ranges, which tells us that people are living longer and longer. Compared to this one, we can see very few people in the older ages, which means there's probably a higher death rate in that population.